Bismillah ar-Rahman ar-Rahim. I hope that you hear me. My name is Tahir Saleem. I'm the owner of a United Engineering Services, and this is a consulting firm providing services in electrical engineering to all sort of the people, especially in industry. We have selected this topic, and this time I'm talking in English because of some foreign interest in the webinar. On their request, we have decided to conduct this in English. In fact, this is a very important topic, and renewable energy. Nowadays, it is very important. And my experience is, and I have observed that the non-technical persons are conducting all sorts of surveys, technical assistance to the customer, all that sort of the things. Nobody knows about the renewable energy problems, how to select your photovoltaic cells, how to select your voltages, and how to select your charge controller, either a hybrid controller, what sort of then the lot of people face problem after the installation. So that's why we selected this topic, and my associate Saifullah Baloch will explain. He have prepared a very beautiful presentation in this regard, and he will tell you how to do the things. Whenever you want some sort of the renewable energy sources, so how to select your batteries, how to select your PV cells, what load should be there. There's so much things. So I just hand over to Saifullah Baloch to continue with the presentation. Thanks.
Thank you very much, sir, for giving me a chance to speak again on a webinar. So today I would like to share something about photovoltaic cell, photovoltaic system, which we are implementing in our houses. So let me share the screen. So today I would like to add in your knowledge about the standalone PV system as per the IEEE standard 1500, 62, 1013 and 1361. These are the different standards in IEEE regarding selection of PV, selection of lead acid batteries, and how to calculate your load, and these all things. Because we find many people who are concerned with these technical work, mostly they are not, they are self non-technicals, and these standards are mostly ignored. So today I would like to add these things in your knowledge, because if you are going for buying any standalone system, any kind of PV cells, batteries, so you must have enough knowledge regarding these things. So first, as you all know, many of people say that any PV system, any solar cell which converts solar energy, it gives you 100% of that. That is not true. That is totally fake. Only 18 to 23% of in conversion efficiency you are getting from any kind of PV cell. So that thing you have to keep in your mind, that your solar cell is not totally efficient. If it would be efficient, then only a 1 hour of total sun energy which is coming towards the earth is enough to fulfill the demand of the whole year for the earth. So this thing you have to keep in your mind. The conversion efficiency does not lies above 23%, and it depends upon the quality of your cell. Now the module peak power, as you all know, whenever we are going to buy a panel or a module, people will ask you how much watt do you want. अगर हम उर्दू में कहें तो वो आपसे पूछेगा आपको कितने वाट का चाहिए. So whatever, you have to keep in your mind that how much peak power do you want from that PV cell, and based upon that you have to select your number of cells, and you have to then firstly you have to calculate the load, and then you have to go for your peak power module or required power, whatever there is. And this module peak power you will find in the back on the back side of the panel. There is a chit, or you can say a nameplate, where you will find the module peak power, short circuit current, open circuit voltages, and these all things you will find already on the back side. Or if you are going for any company manual who is manufacturing such PV modules, then you will be easily finding those ratings. Now This standard condition, when we speak there is standard test conditions, so it refers to some basic criteria, basic parameters. That is, the standard test condition are includes solar irradiance of 1000 watts per square meter and a temperature of 25 degrees Celsius. This is the these are the parameters you have to keep in your mind while saying that these are the standard test conditions. Okay, now peak output is only obtained if the PV system uh, is perpendicular to the solar radiations. And you all know, this is a common sense, that when a light incident on any panel, it will produce the maximum output if the rays are totally perpendicular, exactly perpendicular to the surface. Now, the array to the load ratio, the total ampere photovoltaic amperes are divided by average daily load in amperes hours. This is array to load ratio. What is array? Array is arrangement of cells. When we having two or three panels, this is called array. So when we are taking a ratio, a mathematical ratio, then it will be with the load, then it will be array to the load ratio. Now, autonomy, the length of the time that a photovoltaic system can provide energy to the load without receiving energy from the PV array. Now, as you all know, if we are talking about standalone system, either we are talking about a grid tied system of on grid system, then we must have an energy storage system that are batteries, that are mostly batteries, because no other technology is replacing that nowadays, but only the batteries. So if the sun is not at the time you are running your loads on without sun hours, then that power you are taking from the batteries. So this length of time is called autonomy. Charge controller, as you all know, charge controller is that which controls the voltage, the current coming from the PV cells to the battery and charging it again and again whenever it needs, whenever it discharge. Now, solar irradiance. Solar irradiance actually a factor of measuring how much solar energy is coming to the earth, and this factor depends upon different geographical areas. Like in Pakistan, we have Alhamdulillah blessed with more than 7 kilowatt per meter square per day solar irradiance. And if you take the example of any European country like Germany, they have in the range of 2 to 4 kilowatt per meter square per day. So these factors depends upon different geographical areas. So you have to also design your system and keep these factors in your mind. And mostly the softwares which are used for designing solar systems, they have this factor already built in for solar radiance, then on which location you are installing this PV, and that will add this solar irradiance factor in that designing. Now, sun hours. Sun hours, when sun rises, it does not guarantees that at the time of sunrise you will get the maximum power on your PV cell. Then the total at that time after the sunrise, when sun rays are incidented on the solar panels and till the sunset, how much time the sun is present to produce the solar energy, solar electrical power from your PV cells because of the sun. So this total length of time at when the sun having the at least irradiance of 1 kilowatt per meter square. Tilt angle. This is one of the most important term which I would like to add. That tilt angle, it actually refers to the position. It actually refers to the angular position of the panel. Tilt angle, as you see in the picture, that on an house there is 35 degrees 35 degree of angle is used over here. Now, how you will select this tilt angle? The selection of tilt angle depends upon the latitude of your position, and this latitude you will find on the Google. it is easily available. You will just have to write the coordinates of that city which you want to where you want to install your PV. Like if I want to install at Karachi, then I will just add the coordinates of Karachi. It will give me latitude as well as longitude. So if I have nowadays we have summer starting, so in summer you have to minus tilt angle latitude minus the 15 degrees, and you have in winter you have to add 15 degrees with your latitude, and then you have to select the tilt angle. So this thing is very important, and you have to be careful, because if you want maximum power and maximum efficiency, then you have to choose this tilt angle. These are the calculation which I have just shown over here. That for example, if winter is going on, then you have to add 15 degrees with the latitude. Like in Karachi, we have a latitude of 24.86. This is the latitude of Karachi. If you add 15 degrees, it will be going to 48.86, approximately 49 degrees. So your tilt angle for the PV must be 49 degrees, at least 49 degrees. Now, some other thing which I would like to add up regarding the tilt angle, that data is also available at the meteorological stations of your local councils. You just need to go there, contact them, and ask for this data, that how much solar irradiance I will get at this and this tilt angle. So there are hundreds of tables, hundreds of graphs which will help you to know about this. And this, remember, tilt angle is very important, because it will help you if you just put for example at the your PV cell at the 45 degrees, then the solar irradiance on that solar panel will be very minimum. So this will reduce the power produced by the PV cell. Tracking structures, in Pakistan on the domestic level, we don't find such tracking structures which will help you to find MPP, the maximum power point. So we have a lack of this tracking structure, because it will make the low powered solar system or photovoltaic system very uneconomical, because tracking structures are themselves very expensive, and you have at least that much bigger system for making it more economical. And you have to keep this economical orientation. You have to keep this thing in your mind, that you don't need to make your system such expensive that the energy produced by it becomes very low in comparable to the price. So you have to keep this thing in your mind. Azimuth angle, this is just a simple terminology, that it is the angle which is made by the sun to the normal to the north. So it will it just only verifies a point, that why we are putting our solar panel facing either east, west, or south. In general, we are putting in the south, on the south face. Why not on the north face? Because if you put on the north face, then there will be only 1 or 2% solar radiation will be incident on that PV cell, but you have to put that solar panel facing the south. So this angle just only shows that why it is important to face your PV cell towards the south. So this is the graphic pictorial representation of azimuth angle. Now the introduction. Solar energy is the conversion of energy from sunlight to electricity. Everyone knows about that. And there are different, sort of solar devices which converts the solar energy into electricity. They are concentrated solar power plants, and different other technologies are nowadays used. But as we are talking about the PV cells, so we have to remain on that. Now, whatever I have told you, whatever written over here, I have already added in your knowledge earlier. Now, this is the National Renewable Energy Laboratory map, which we have taken from their website, and this shows you that how much solar irradiance you are getting, or solar radiation you are getting on the different areas of the Pakistan. This is the general design how a standalone PV system is designed. And remember, we are here only talking about the standalone PV system. So if you are going for any grid tied system or on grid system, you have different parameters for that. So this thing you have to keep in your mind, that we are just only concerned here with the standalone system. Firstly, the PV array is connected with the voltage regulator or the charge controller or the MPPT DC to DC converter. It depends upon your need. Then there is a DC bus connecting batteries, inverter or DC loads, which you want to feed directly from the voltage regulator inverter that will invert the DC into AC. Then a DC bus which provides to the batteries. Now, standalone PV systems are designed for those remote areas which are not accessible for the grid, and there is a lack of electricity, and there we can only have the standalone PV system to work as a renewable resource. So, standalone PV system has different advantages and disadvantages, which we'll discuss later on. But this thing is, only mostly installed at those remote areas. Okay, so basically in those urbanized areas, we are using the grid tied system or on grid system. So this thing remains here. Now the area requirement for your panels, for your components which you will need while designing the PV cells. So you have to also keep in your mind that where you are going to install these PV cells for your concerned load. There is a simple thumb rule which we use, that a single or a kilowatt, 1 kilowatt needs 10 square meter of area. Having a length of 10 or having a length of 10 or width of 10, you have to keep this in your mind, that it needs 10 square meter or 10 square feet, 100 square feet area for your 1 kilowatt power plant. Now the best option is ground mounted solar arrays, but for that you need a bigger area, and you have to purchase that land where you are going to install that solar panels. But as you are installing it in a domestic region, then the most easiest way is the easiest way is to install your solar panels at your roof. So this will save your area and save your money also. Like this rooftop I was showing here, I've showed you in this picture, that a solar panel is installed on the roof of a house. Now the sun hour method for PV array sizing. A simple method for calculating the ampere hour per day which is produced by your solar panels. Now you just need to know about the current which is produced by the solar panel, the maximum current. Then you have to multiply with the solar sun hours. For example, in winters we are having 9 hours of sun, so 9 multiply by the total current which you are getting from the solar panel, that will gives you the ampere hour per day. Now before going to PV sizing, we are we need to calculate the load, because if you are going to calculate that how much energy, what amount of generation do you need, first initially we have to know about the load, that how much is the demand. Then we have to calculate that generation, that how much generation then you need for that concerned load calculation. Now basically in load calculation, many people miss those important factors which we need to include in our load calculation. The overall duty cycle imposed on a battery is the description of the DC load current and its duration within the autonomy period, during which it's assumed that no power is provided by the PV array. Now mostly the people who design, who are non-technical especially, they do not include the battery load actually, that because battery itself need specific amount of power to charge itself. and specific amount of power which we need to supply to the battery for charging it. So you have to include that. Now, for AC load supplied through inverter, these loads should be tabulated separately, totaled, and combined with the inverter losses to determine the actual DC load on the battery. Now, for the inverter, you have to know that what is its efficiency. For example, if you are having an inverter of 10 kilowatt, if you are choosing inverter of 10, 12, or whatever rating is available in the market, then it don't think that it will totally handle those 10 kilowatt load. It will go for its 85% of the total rating, because it contains some losses which are inversion losses, or these all things you have to include. Now, the system's load can be expressed in a tabular or graphical form. Now, if you are going on a detailed study, then you have to choose the graphical method, because it will show you that at what time what load is running on your system. So it will help you to design your system more efficiently, more with a more detailed way. And if you are going for the tabular form, you, this is also a method, but in a graphical form we prefer for the detail study. If you are going for the detail study, you have to choose the graphical method. Now, the load profile diagram, the graphical representation is necessary to visualize the interrelation of the individual loads, so that I have already told you. Now, for the both load description, all load expected during a 24-hour period are tabulated along with their anticipated durations. Now, if those loads which are running 24 hours in a 24-hour duration, you have to multiply them, you have to calculate them with their specific duration of load. So this term is also included in the next slides, that duration of loads. It also varies, depends upon the load, because if you are using an iron, you will not use it for 6 hours, you will use it for 1 hour. And if you are using a fan, it will mostly in our domestic areas, we are using a fan for nearly 18 to 20 hours, and if you are using a refrigerator or a freezer, we are using it more than 18 hours. So these duration of the load also changes, and they also need a special consideration for that. It may be necessary to consider a longer period when 24-hour period does not accurately describe the load profile. For example, if you are having those loads which you run one time in 2 days, so you have to make your load profile more than 24 hours. You have to choose then 48 hours for describing your load profile. For those cases where the load profile exceeds 24 hours, an average and maximum daily load should be determined for subsequent battery capacity determinations. Then you have to calculate your battery, then you have to size your battery, depends upon that load which is exceeding 24 hours, or those loads which are included in the load profile having 48 hours. So then you have to change your way of designing your system. Then you don't have to look for the 24-hour, you have to go for the more than 24 hours. Okay. Once the battery has been sized, the maximum daily load is used to determine the ability of the battery to sustain it. Now, after designing the battery, your battery must have a handling capacity of taking that maximum load. For example, you have designed your battery for an average load of 230 ampere hour. Then, if you are having a maximum load of 400 ampere hour for the number of batteries, then you must be assuring this thing, or having a guarantee of those battery, the manufacturers, that this set of batteries will handle the maximum load. So you have also you need to go for the worst case, and this thing will help you out, because mostly when we are having the maximum load running over our system, the components fail to handle that, and that reduces the life of the system. So this thing you have to keep in your mind, that maximum load handling must be assured in your system. Now, if the maximum load sequences cannot be established, and a complete day, then you have to go for the worst condition. The battery capacity may need to be increased to satisfy the maximum load in the partially discharged state. Now, this thing I have already included, that if your battery is not, you know, handling the maximum load, then you have to increase the size of the battery or increase the number of batteries. For the application where load varies significantly on the monthly basis, the average daily load for each month should be determined. Now, for example, if any load which you are running on your system, like if you are using any single appliance to a single time in 2 months, then this changes the load on you. Then you will not need you will not be able to rely on the single month data. You have to go for the 2 months or number of months. Then you have to design the system, and then you have to go for the average load for the month. Now the battery sizing should be based on the resulting maximum daily average load. Momentary currents. Now, in our American system, in our European system, IEC system, we call it as an inrush current. If someone says that momentary current, then you don't need to have to confuse that what current, or what the source of that momentary current. It's just inrush current. Okay. Now, what are the sources? There are two sources: the motor starting currents, which mostly the induction machines, and the high inverter surge currents. Now these surges, these are the momentary currents or inrush currents, and you have to give them special consideration in calculation of your system. And those momentary currents which having a duration of more than 1 minute, then you have to give them a specific load. Then you have to include them as a load. But in our system, the momentary currents like uh, induction motor starting currents, these last for 1 or 2 seconds or 3 seconds. Then you don't need to add them as a load. You have to just keep this in your mind, that the inverter or the charge controller or the simple controller which you are installing in your PV system, that must be able to handle those surges. This surge handling capacity must be already installed or built in your controller, but as a load it will not be included in the calculation if it lasts less than 1 minute or less than 1 or 2 seconds. It will not take any special load as a load. You will not include as a load. Now the running currents simply the amount of current which is flowing in your system, and that you will include as a load. And it this is the thing which you will take to calculate the ampere hour. Now, for the typically long rate discharge of PV application, the battery voltage remains relatively constant until near the end of discharge. Now, this term end of discharge, that add the 80% consumption of the battery. If the load has consumed the 80% of your battery, then the voltage which you are getting from that battery at only 20% remaining capacity, that voltage is called EOD. And this thing you have to keep in your mind, that the load which you are running on your battery or storage system, the voltage which remains at the 20% remaining capacity, the voltage present at the terminals, the system, the load, it is not less than the voltage must not be less than the minimum voltage required by the load. For example, if you are having a battery of 12 volts, and in market we have available the maximum voltage we are getting from the battery is 12 volts from single battery, then if at the lasting 20% of the remaining capacity, it will, if it gives you 11 volts, then the load which is connected to these batteries must be able to sustain at 11 voltage. So this EOD voltage have to be not less than the total voltage required by the load. For the certain load, it is necessary to consider both the momentary and the running load of the component. Like, for example, if an electric motor starts during the duty cycle, both the starting current and the running current must be considered. Now, the duty cycle, those who are concerned with electrical engineering, they must be know the duty cycle. I will not go in the deep because it's those who have studied the waveform, they know about the duty cycle. Okay. Parasitic current, uh, in biology we have some parasites. Those eats the meat, or those destroy their neighbors. These are called the parasites. Now the parasitic current in PV system, these are the losses. Actually, these are the losses which are included from the inverter, which are included from the charge controller, or the wire losses. These all currents are included as a parasitic current. So this factor which we have to also add in our designing, that parasitic current must be not ignored. Because if you are having a system of uh, for example, it produces the 500 ampere hour, and if you have not include the parasitic current, then the total current which you will get from that, you will easily you will only get 415 ampere hour, because 50 ampere hour will be included as a loss. So this factor you have to keep in your keep this thing in your while designing the system. Load duration, which I've already told you, that load duration is important, because the amount of current needed required by the load multiply with its time, it gives you an ampere hour, and that is actually the rating which you need. The minimum and maximum load voltage, this is called the uh, voltage window, that it gives you the limit, the upper limit and the lower limit of the load. Because while we are designing our PV system, as I've already given you that example in the battery, that if a battery having a minimum voltage of 11 volt or a maximum voltage of 13 volts, then your load must have a handling capacity of this both limits, that at the maximum 13 volt the load can handle that one, and at the minimum at the 11 voltage that have to be sustaining and continue its operation while this minimum voltage. So this voltage window is also included as a very important parameter while designing system. And this I've already shown that, giving you an scenario that after the voltage drop due to the losses or due to the discharge capacity, the voltage which you are getting at the load is less than the designated voltage. So the load and battery must have a handling capacity for that. Ampere hour, the total load multiplied by the duration of that load gives you the ampere hour. Now the momentary load, if for example momentary loads are not known, then you have to take it as a 1 minute, then calculate the load accordingly. PV sizing. Now PV sizing, firstly you need the accurate solar radiation that you will be getting from the meteorological stations, or you can just go on the website of National Renewable Energy Laboratory, or there are hundreds of websites which you will able to take from the Google, and you can get the data easily for designing your system. Okay. Now, the value is usually represent the solar radiance is given in the kilowatt hour per meter square. That how much electrical energy units which you are getting from the sun per meter square. Okay. Now, if the load is not constant for all months, the array and the battery will need to be sized for each month. The month with the lowest array to load ratio and the battery autonomy should be used as a worst case for the system design. Now, battery, if you are having a loads which are not constant over the 12 months, then you have to be designing the battery or the PV with depending upon by looking at the load profile for the each month, and you have to go for the worst case when you are having the lowest array to load ratio, for example, and then also with that the battery autonomy should be used worst case for the system design. That worst case means for the lowest design, for the maximum autonomy you have to design the battery, and this will be an iterative process, because we need to always check the capacity of our batteries for the each month and for the load which is changing each month. And this is in case for those which are having the loads different in each month. PV area sizing, now it is determined the solar determined by the some factors that, those are solar radiation, area to load ratio, system losses and load. Now, for the PV module selection, now mostly people, they do what? They just go and ask for the PV cell. They do not say that we need a monocrystalline, polycrystalline, and the material which is used for in the manufacturing of that solar panel. So, and these things you have to keep in your mind, because a design engineer knows that what kind of material is required as per the climate of that location, as per the load required, as per the temperature coefficient, and these things you have to keep in your designing of the system, because it is very important. Mostly people don't know that what material is affected by shedding, what material has maximum efficiency. So these things must be kept in designing. Now, there are different kind of technologies which we are using the different kind of material, like single or polycrystalline silicon, amorphous silicon, copper, indium desalinide, cadmium telluride, hybrid amorphous single crystalline silicon modules, and these different technologies are now available in your markets. And the mostly which is available, and now the most important thing, that for a desired voltage, if you are needing a voltage of 48 volts, then you must know the voltage given for the each PV cell. For example, if you are having a 12 volt module, then you have to connect the four modules in the series to get 48 volts at the end of the terminals. So this parallel and series configuration you have to keep, and this depends upon the voltage and the current which you need for your system. Now, crystalline silicon PV modules. Single and polycrystalline silicon modules have been used in the longest and make up more than 80% of the worldwide PV market. As you can see, the solar panels which are installed mostly in our domestic regions or in commercial areas, those having two colors, one is black and another is blue, sky blue, or some having a bit of dark blue. So this represent the material used for that. For the black, it is monocrystalline silicon. For the blue, it is a polycrystalline silicon. They are 80% of the world is using these this material in PV modules. Although single crystalline cells are slightly more efficient than polycrystalline cells, and module efficiencies employing either technology are nearly the same. If you are going for the efficiencies, they having mostly the same efficiencies, and depends upon the the different loads, different parameters for these two materials. Like typically crystalline silicon modules are more strongly affected by shedding. Now this thing, mostly people don't know that crystalline silicon, they are having a very bad effect, and they are badly affected due to shedding. If any shed, like if you are installing the PV cells on your rooftop, the trees nearby your house, if their shed is coming on those PV cells, then PV cell will drastically reduce their output due to the shedding, and they are strongly affected if the material of crystalline silicon is used in them. Now, crystalline silicon modules have a higher temperature, coefficient than amorphous silicon. This higher temperature coefficient, what that means? That means that whenever the temperature increases, whenever the temperature of the surrounding, that climate, if the climate having a temperature, that increasing, then the output will reduce with that same rate. If the temperature is 25 degrees, you are having an output of, for example, 300 watts, and if the temperature is increased by 2 times, then the output will decrease more than 2 times with the same rate the temperature is increasing, huh? And with that power output, the voltage also reduce. Now crystalline, they have a rigid structure. They are very strong, they are heavy, and these having a large number of ranges for the power output. And mostly you can see the PV modules having this crystalline silicon. If they are made up of crystalline silicon, you will find a range of more than 400 watts for these panels. You know, now amorphous silicon, they have efficiency of 5 to 7%, and that is the half of the crystalline silicon. Now the point which we are having now, this thing, you can notice that the temperature coefficient is lower in silicon, amorphous silicon, but the efficiency is totally half of the crystalline silicon modules. Now 5 to 7% of that totally silicon, only that 5 to 7% is the efficiency of these amorphous silicon, but they have lower temperature coefficient than the crystalline silicon. So it depends upon the climate which you are having. If you are a higher temperature, then it is recommended for the amorphous silicon manufactured PV modules, but you have to keep the efficiency factor in your mind. And the amorphous silicons are available up to 128 watt, so it having a lower range of output or power output which you are than the crystalline modules. Now this is another technology, CISPV modules, and it having only these are only available in the market with a percentage of only 0.5%, and they are only having efficiency of 9.5%. So as the time goes, as the time if you are if you go in the future, then we can predict this, these new technologies will try to improve, and it will come up with the more efficiencies in the future. These are just only I'm adding in your knowledge is that these technologies are also used in nowadays in the world. This another technology which is Cte Pv modules. These having efficiency of 6.5%, having a range of power output of only 65 watt. And there is another PV technology, HIT PV modules. Okay, these are having a range of only 190 watt, and it has a higher efficiency of 16%. So it can be comparable, and it can compete with the crystalline silicon modules because of the higher efficiencies than the other technology. Now the self-regulating PV modules, these are the most, the basic advantage which you are getting from this module, that it has a output voltage of more than crystalline silicon modules having due to the increased number of cells. Now conclusion in module PV selection. Before choosing the system, before designing the system, the operation of the load and site climate must be known. So two things which I emphasize, which our design engineer will emphasize, that you must have two datas: the operation of the load and their site climate. And site climate refers to the climate of that position, of that location, of their geographical parameters. You must be knowing that. And the designer must know the power required by the loads and input voltage range. And the solar radiation, which also includes in the site climate, because it's refers to the geographical data, so it will be available in combining with all those temperature or whatever included in the climate data. If the solar radiation is typically low during the time of the year, the load demand is greatest, the area size will have to be increased. So these depends upon actually the load, the demand, your demand. So you have to design the system with these variable demands. You have to design with the worst case, no? Whatever just included in the conclusion side, I have already told you in the earlier slides that what voltage, uh, what magnitude of voltage, what lower and upper voltage you need in your system, and these all things. Now, system losses, you must include system losses, and these are more than in a range of 10 to 20%. Now it depends upon the charge controller which you are using, the wires, the quality of the system, that all depends upon these parameters. So the system losses must be included. Now this is the method which we are using for the determining the number of series connected modules, because when the modules are connected in series, the voltage is added, and this number of series connected modules depends upon the voltage requirement. And this is the formula: ns is the number of series modules is equal to the voltage of the system which is required, and divided by the voltage of the module. The n number of series if you are getting any not a whole number, if you are getting a decimal, any number which is in the decimal in a point form, then you have to increase to the nearest whole number. Now the parallel connected modules, uh, these parallel connected modules depend upon the you know the number the power output, the sorry, the current output which you need. For example, you have a demand of current of 20 ampere, and each module having a current rating of 5 ampere. Then you have to connect the four modules in parallel for giving you a current rating of 20 ampere. So this is just a simple configuration which an electrical engineer or a simple designer will know about, have must know about these things. Now, battery selection. Now the battery selection, it depends upon the functional hour rate. Functional hour rate is determined by the capacity and the load calculation, na? That what is the capacity of that battery, and what is the load. Then it will give you that how much hour you will be having autonomy on the battery. Battery characteristics. Now, I will not go in the deep of that, because a battery is nowadays very common. But being an engineer, I would like to add some points which are important, and which a technical person only know about these things. Na? So first thing which you know must notice the characteristics, and you must know about these things regarding the battery: the temperature effects, the recharge efficiency, the sulfation, the charge voltage, the possible PV design solution for the optimum battery health. Now, and depth of discharge, the end of life, these things, the battery having these ratings, and a design engineer must keep all those things while battery sizing. Battery types, if you are talking about the vented batteries, these are very much you know important, because nowadays, and from from the decades we are using this vented batteries now in our PV systems. Those you can see, like those are used in same as cars, in the domestic UPS systems. So what their shape is, I will not talk about that. But the important point I would like to add, that due to overcharging, and due to the consumption, and due to the cycle repetition of the battery, cycle repetition means the consumption from the battery, actually it evaporates the water. So this water, you need to fill it again and again. So this is the bit, you can say, a disadvantage of this vented batteries, and it having a low power rating, lower life than the other kind of batteries. Wall regulated batteries, these are very much efficient than the vented batteries. And both these valve regulated and the vented batteries, these are both deep cycle batteries. And they are also used as the cranking batteries for the in the car starting. But these are both deep cycle batteries, And in vented battery, in valve regulated batteries, we have a advantage over the vented batteries because it reduces, it has a reduced water loss by the overcharge. Na? During overcharging, it has a lower water loss than the vented batteries, and it has a higher life than the vented batteries also. Now, in the last, I would like to add a design example. So this is the data which I have taken from the National Renewable Energy Laboratory, that, and I have taken the worst case, the worst solar radiation, because while designing the system, we have to choose the lowest solar radiation, because if you choose the higher one, then your system will be undersized for the designated loads. And here the lower one is 5.3, sorry, 5.32 or 5.26. I have took their average as 5.3 kilowatt hour per meter square per day. Now, if you are having these loads, I would not tell you about the number of loads, the wattage. It's total written. I have just give you the headings, that what is the wattage of each load, what's their quantity, the total wattage and the duration, and then the watt hour, and total watt hour required in a day, that is 52,330 watt hour, which we need per day. Now the load, firstly, initially the load calculation, 52330 watt hour per day, and we have to convert it in the ampere hour. How you will convert it? You will just simply divide with the system voltage of your inverter, the DC voltage. Na? As these bigger systems have higher voltage rating, you will not able to run the system on 12 volt. On the 24 volt, you have to go for at least 48 volts because of the higher rating. So if you divide with the 48, it will give you the required ampere hour, that is 1090 ampere hour. Now the battery sizing, for the standalone system we need deep cycle batteries, and these are specially recommended. Now, the days of autonomy. How much days you need the battery backup system? Simply, we will need a single day, because on another day we will be having a PV system for the recharging. Now, allowed DOD. DOD is depth of discharge, that how much battery is allowed to discharge, because in the UPS or in your controllers, the limit is already built in, that if the battery is discharged to its 80% capacity, it will start to beep, and it will turn off the system. Because if you use that system after 80% of its capacity, the battery life will be reduced. So it's a feature, it's a advantage of the controller, that it will automatically turn off your system if you are exceeding more than 80% of the total battery capacity. Na? So how you will know about the battery capacity is that multiply the ampere hour with the days of autonomy divided by the depth of discharge. So we will choose that we will be getting 1363 ampere hour of a battery for 1090 ampere hour required ampere hour. Now the battery select, if we are selecting the battery of 230 ampere hour, we have different battery ranges available in the market, but the highest one which is available nowadays commonly in the market, that is 230 ampere hour battery. So number of batteries which we are getting, we have to connect in the parallel due to the capacity demand. The total battery capacity divided by the selected battery capacity, that is 230, it will give you 6 batteries in parallel. So 6 batteries in the parallel you have to connect. And now, because we have the batteries which we are selecting, and the standard battery voltage is 12 volts. So if we need the 48 volt in voltage input to the inverter, we must have the battery is connected in series, and there must be a number of batteries. Then how many number of batteries we have connect for the 48 volt output? Then 48 divided by the 12 volt for each battery gives you 4 batteries in series. Now, how will for calculating the total number of batteries, we must multiply the number of batteries in the parallel and in the series. That 6 batteries in the parallel multiplied by 4 is equal to 24. So total 24 batteries will be required to handle the load of 1090 1090 ampere hour required load. So it will if we say in just in simple form that six strings must be connected in parallel, each string having a number of batteries of four number of batteries are connected in each string. Now PV sizing, it's simply the watt total demand of the energy, that is 52,330 watt hour per day. Now PV adjusts capacity, because if you are having a PV cell or PV module of 450 watts, it will give you only its 80%, that is 360 watts. So the required total PV capacity will be calculated by the total energy required per day divided by adjusted capacity, that is 0.8. Then if you divide the 52,330 divided by 0.8, it will give you 65,413 watt hour per day, that you total power energy you need per day. And sorry, that is the total installed capacity of the PV cell. Now the selected PV voltage at standard test condition is 40 volts, because if you are selecting PV cell of 450 watts, it will have a nominal voltage of 35 to 40, or 40, sorry, 40 to 45 volts. So if we have selected a nominal voltage of 40 volts, now the guaranteed power output, because the guaranteed power output of 450 watt is 360, that is it's 80%. Now the total sun hours, the energy output from the panel, that is the guaranteed power, the guaranteed energy, because the guaranteed energy is 360 multiplied by 9, that will give you 3240 watt hour per panel for the 9 hours. Okay, that is not for 1 hour, that is for the 9 hours, the energy which will give you will take from the panel. Now if you are calculating number of panels, simply divide the total energy, total installed capacity divided by the watt hour per panel. That is 3240. It will give you the 20 panels. Now, the number of modules required. Now, this you will install in the parallel 20 panels in the parallel, because the parallel configuration gives you the capacity, and for the voltage you must have that 24 volt system divided by the 40. Now this 24 you have to change it with 48. 48, it will gives you 1. Okay, now there's a typing mistake. There must be 20, not 24, there must be 48, because you have a common bus voltage of 48. 48 divided by 40, it will give you more than 1 point, it will give you 1 point something, but then we can round it up to one panel. So you have to connect the 20 panels in parallel, and 20 strings, and each string have a single panel. So basically you have to connect 20 panels in parallel, and 20 panel must have the voltage rating of 40 volts and the power rating of 450 watt. So total installed capacity will be 9,000 watt. By multiplying 450 watts multiplied by total number of panels gives you the 9,000 watt. Area requirement, one, it's a I've already told you the thumb rule. The 1 kilowatt PV system need 10 square meter area, so 9 kilowatt PV system will require 90 square meter area. Inverter calculation. Now I've already told you, for the inverter calculation, that 1 kilowatt PV system needs 10 square meter area. So for that same in our system, 9 kilowatt PV system will require 90 square meter area. For the inverter calculation, your inverter must be able to handle the surges from the inrush current sources like motor starting and the inverter itself surges which we are getting from the system. So this handling capacity must be kept in mind while designing the system. The inverter calculation, like the total power flow through the inverter, because 360 watt is the guaranteed power which we will get. We will not be getting the power above than 360 from a 450 watt panel, because it has efficiency of 80% only. So the total power flow will be 7200 watt, and the inverter required will be at least 15 to 20% higher rating we have to choose for the inverter. So it will give you 8640 watts. Now, as we know, this rating of inverter, this rated inverter is not available in the market, so you have to choose a higher rating, next higher rating than the from this calculated rating of the inverter. So after 8000 watt, we have a 10 kV inverter available in the market, so you have to install a 10 kV inverter. 10 kVA or kilowatt you have to choose. Thank you very much for listening this presentation, attending this webinar. If you have any question,
My question.
please.
First question.
Yeah.
My question
So
is,
first,
an expert.
yeah.
As an expert, what you suggest? What type of the PV cell I should select? What type of the battery I would select in a Karachi environment, in Pakistan environment?
Sir, as I've already told you, that it depends upon the load and in your climate. Because in Karachi we have a higher temperature coefficients, but the crystalline silicon PV cells can handle that. So you can choose the silicon because of the higher efficiency. You can choose those, and for the battery, it depends. You must select the deep cycle batteries, and for the if you ask about the brand, I will not recommend any brand because it's not we cannot make it a source of publicity for them. We are not sponsored especially from them. So it depends upon the rating. It's upon the load, it's upon the load flow, and you have to calculate all these. So we have different softwares you can use for the load flow analysis of your system. Then you can choose your desired or required battery.
Now I can design for my house.
Yeah, you can design for your house.
Don't go for the market.
Okay, sir, how we can decide tilt angle for both season? We need to change on season basis. You need to say 15 plus in electron. Then threshold. My second question is charge of the 820 series.
Repeat the question.
No, the question is, he's asking about the tilt angle. That how much tilt angle we can choose, the optimum tilt angle. Now, my friend Muhammad Hamza, the tilt angle which you have to choose for the both season, you have to choose the optimum for that. For example, uh, latitude minus 15 degrees, latitude plus 15 degrees. Then you have to make a graph, and then you will check that where it crosses, that will give you optimum. Or simply you have to add both those angles, the resultant angle after detecting 15 degree and adding 15 degree, add them and divide by 2, it will give you an optimum angle. And but remember this thing, this is an mathematical simple algebraic calculation, and I would not recommend to rely on this calculation, because this is not an you can say recommended calculation. Na? The data, it is available at the local meteorological stations. You can just go there. If they if they are having, in Pakistan we are lacking this thing, but in foreign countries you will find an optimal tilt angle for your PV design, PV system at your location, at your desired location. So the meteorological station, they will provide you that what should be your optimum tilt angle. But by the algebraic calculation you can go for it, or by the graphical method you can also go for this calculation, but I would recommend that go for the local body meteorological stations. Na?
But the meteorological department don't give such error.
Yeah, they have not. Mr. Nizamuddin,
Pakistani environment.
my very good friend, he has added this very good information by the software. Yeah, we have. He has included the PV system and the RET screen. So RET screen, this is also in the software, and Homer. This is also in software for designing the renewable energy system for the local, for your domestic or commercial load system. You can also use these softwares. So this is the very good way, na? Because in our local meteorological station we are not finding such data available. So you can use the software.
These softwares are free, or
no, these are not
purchase it.
There are different variety of software. You can purchase them, and you can also avail the free resources from them. Na? So what is the benefit of bifacial bifacial panel and how it improves efficiency, and also used to improve the efficiency. Sorry, Mohammed Hamza, I'm not aware about this bifacial, but uh, if I go for the dictionarial meaning for that, uh, for the improving efficiency, bifacial means two faces solar panel. So you have to choose that one. Mashallah, my project engineer he has very much expert, more he has experience of more than 5 to 10 years. Okay, so he has added that in Pakistan we have this new technology is just started nowadays, but it's very expensive and has a very improved efficiency in the solar market. And there is also another technology, per polycrystalline technology, na. So and sun tracker, it will it is yeah, it has a benefit of improving the efficiency, because by sun tracker you can you can able to track the MPPT, na, power point, maximum power point tracking. So it depends upon the position of the sun. Wherever the sun goes from east to west, from sunrise to sunset, it will track that. And these trackers are already made by many of the thousands of students in their final year project or the mini project. They are using these sun tracker for improving the efficiency, but it's expensive for such higher system, na. Nizamuddin has added that RET screen is free, so you can Mr. Hamza, you can use it for free of cost, and you can able to design your system on this. My question is to charge of 100 ampere hour, 8 batteries in series. 8 batteries in series. If and two strings total battery can be set with 5 ampere, it is takes how much time to charge? इसके हिसाब से तकरीबन ये 5 एम्पेयर के हिसाब से हाँ तकरीबन आप इसको 8 घंटे का टाइम लगेगा इसको 8 घंटे ओके सीरीज में कैसे होंगे कितने वोल्ट की बैटरी है वो डिपेंड करता है उसकी वोल्टेज ओके लेकिन ये टोटली डिपेंड करता है कि आपकी चार्जिंग एम्पेयर कितनी है हाँ चार्जिंग बैटरी को जो है ना वो कितना उसको यूज किया लेकिन एक जो जनरल स्क्रीन नहीं नहीं ठीक है जितना थंब रूल है ना जितने जनरल के हिसाब से अगर चलो ना कि 10 एम्पीयर अगर 100 एम्पीयर की बैटरी है और अगर आप उसे 10 एम्पीयर पे चार्ज कर रहे हैं 10 एम्पीयर के साथ चार्ज कर रहे हैं और अगर वो 80% आपने उसको छोड़ा है और 20% तो इसको तकरीबन 4 घंटे लगेंगे 4 घंटे लगेंगे सो फर्स्ट थिंग if you are connecting 8 batteries in series, then I would like to know about the voltage. Actually the series connection gives you the voltage addition, na. So it depends upon the voltage and how much voltage do you need from the and how much your battery is rated. If you are, for example, if you are having a battery of 20 volts of 100 ampere hour, then if you are connecting 8 batteries, then it will give you 160 volts in series combination at the terminals, and two string in total. It depends upon the capacity. And if you set the 5 ampere battery for 5 ampere capacity for each battery, it depends upon the charging current, and we take 10% of the total battery capacity as a charging current. For example, if you are 100 ampere hour battery, the 10% will be 10 ampere. So 10 ampere, if you are charging the battery at the 10 ampere, it will take 4 hours to charge it. And are VRL battery suitable hot climate? उस कंडीशन के अंदर 4 घंटे लगेंगे कि जब आपने उसको जो है ना वो 80% मतलब जो उस पे चला गया छोड़ा 80% रखा उसे okay, if and this is only applicable if you are using it at 80%. 9.6 वोल्ट होता है ना हाँ 9.6 वोल्ट अगर उसके बाकी रहे हैं और उसके ऊपर वो कट ऑफ करवा दिए okay. अगर आप 8 वोल्ट पे आ गए हैं तो फिर और ज्यादा टाइम लगेगा yeah if you have used the 80% capacity of the battery and then you are charging it with the 10 ampere, then it will take 4 hours, and if you have consumed more than 80%, then it will take more than 4 hours, na. So VRLA batteries are suitable for hot climate, the vented. No, they are not, because it you need to know about the ambient temperature handling capacity. Yeah. So it depends upon the battery, you know. गुड़ जितना डालो उतना मीठा होगा VRLA बैटरी में एयर कंडीशनिंग रिक्वायर्ड है So it depends upon the rating of your battery. You can check it out that how much ambient temperature it can handle. Okay, any other question would like to ask and you would like to add in my knowledge? No, I'm not. Sorry. Mail कर दे हमें. बोला अगर कोई question है तो मैं mail कर. हाँ, okay. One last thing. Okay, what is the solar production? Is the Pakistan major project? Peer share for the industry knowledge. Solar production. We have a 100 megawatt plant. Qaid Azam Solar Power Park at the Bhavalpur, I think, in Punjab. That is the largest solar park. Solar park. Qaid Azam Solar Park that is located in the Bhavalpur, having capacity of 100 installed capacity of 100 megawatt. But nowadays it has reduced production because of the very low maintenance. And now one thing would like to add that I have learned from my CEO, and I have learning new things every day from my he's my teacher. So this thing you have to keep in mind that mostly people say solar is maintenance less. No, it is not. It is totally not. You have to maintain it more than your other systems. You get an optimized. If you want to get an optimized result. Yeah, if you want to get the maximum efficiency, you have to, and you have to take the complete cost, the complete investment. You have to take care of that. You have to maintain it regularly. Okay, so it is not maintenance less. Okay, thank you very much. If you have any other query, you can ask through the email, and we have shared our email on that website. Thank you very much. Yeah, thank you so much, Mr. Hamza. Thank you very much. Thank you, everyone. Allah Hafiz.